Hello everyone, welcome to the 14th lesson of our RCC building design using ETABS and manual check course. In this lesson, I will show you how you can solve the errors that you have in the model, and I will also show you how to calculate the load for your lift machine room. Okay? And we will create the whole structure also here, because here you can see we have only created the one single story. So we'll be creating all the stories, we'll be assigning the rest of the loads which are left. Okay, so let's get started. First, I will just check the model whether this model we have created is correct or not. I'll go to here, analyze, and I'll go to check model, and I'll click on this select deselect all. I will uncheck this trim or extend frames because I do not want any of my you can say structural elements to be distorted to get fixed. So if there is any issue, we will do the fix manually. So now you can see it will be checking all the joints, it will be checking the frames, the shells, and it will also check the mesh if there is any discontinuity or something like this. And the tolerance length we have provided is 1 mm. So if there is any beam or any slab which is overlapping on each other with the tolerance of 1 mm, it will be checking whether it is overlapping or not. Okay, so I'll click on OK now. Now it will be checking. You can see it has given some warning here. So now you can see it is giving this warning that the model has been checked. Two warning messages: beam in the story level 1, B156 and B181, and B160 and B182 are overlapping on each other. Okay, so that means these beams are overlapping. Beams 156 and 81, 181, 160 and 182. So I'll just, what you can do, you can select all this, Control A, Control C, you can close this, and maybe you can create a text file like we have a previous one. So I'll just Control V and you can paste it here. You can save it so that you can just refer it. So B156 and 181. Okay, so I'll go to the ETABS. I will click on this set display options. I'll go to object assignments and click on labels. And click on apply, close. Now what I will do, I will go to the plan view and story 1. Okay, here you can see it is the beam 156 and here we have this beam 181. Now where is the problem? We need to find out. You can see this beam 156 is coming on this joint. Obviously it is the center of the column. This is correct. Okay, and if I click on this beam, here you can see it is not connecting with the center of the column, but is going beyond. That means it is overlapping with 156. So I will select this beam. I will select this point also. Same thing you can see here. If I see this beam number 160, it is totally correct. But if I see this beam number 182, you can see it is going beyond this column joint. Okay, so I'll select this beam and select this joint also. Now I'll go to this divide frames and click on this break at intersection with selected frames and joints. Click on apply. Okay. Okay, now if I want to delete this beam, it may delete the column also. So I'll just go to select object type, and I will go to columns, select, close. I will right click here, the white background you can say, and I will click on this hide selected objects. Okay, now I will be selecting these beams, the extra beams that we have got here, and I will also select the extra beam that I have got here. Okay, now I will press delete. Okay, now again I will right click on this outer area and I'll click on this show all objects. I'll go to analyze, check model, and again I will check, make sure that these two things are unchecked. Okay, and click on OK. Okay, now it is showing model has been checked, no warning messages were generated. So now the model is correct. Okay, so now we can go for replicating this model. I will just turn off this object assignment and labels. Okay, I will go to the 3D view. Sorry, let me go to the plan view. Okay, I'll make sure that it is in one story. Select all the members here, all the elements here, and go to the replicate story. Remember, it is a S+5 building, so it will be up to from base to story. It is the stilt level, story 1, then story 1 to story 2 first, story 2 to story 3 the second one, story 3 to story 4 the third one, story 4 to story 5 the fourth one, and story 5 to story 6 the fifth one. So already we have created the model from base to story 1, then we will be replicating from story 2 to story 6, and I'll click on apply and OK. Now if you go to the 3D view, you can easily see the structure. Okay, now I will go to the plan view and I will go to the story 6. I'll click on OK. Here I will select the, make sure this is one story. Okay, make sure this is one story. I will select the whole building like this, and I will go to assign frame loads distributed. I need to delete all the loads on this particular floor, so I will select this SIDL and click on delete existing loads, apply. I will close this. Again I will select this. So for that you can go to select and get previous selection. I will go to assign cell loads and I will click on this uniform load sets, and I will click on this none and apply. Close it. So now if you see in the 3D view, there is no load present on this particular floor. I will go to the plan view and story 6 again. Now I need to assign the parapet wall loads. Okay, so the parapet walls actually how it will be, just let me just make an outline how the parapet walls will be getting. So we can assign the parapet walls like this, maybe like this. Right, here it will be a full wall of 2.5 meter height because it will be the lift room. Here it is the stair room, and this wall will also be 2.5 meter height, right, and these walls will be having 1 meter height. Okay, so let us select the you can say the beams for assigning the load. Now here you can see this particular beam, we need to divide it here so that we can assign the differentiate load, different loading on this beam length. Okay, so first let's divide the beam. I will select the beam here. I will select this node, select this beam, this node here also, this beam, you can say this node, this beam, and okay. I'll go to this divide frames, break at intersection with selected frames and joints, and click on apply. Now let us select all these outer peripheral beams. Okay, here it is my duct, so obviously it will be something like this only. Like this one, fine. So I think we have selected all the outer peripheral beams like this. Okay, and I will go to, now I will close it. We'll go to assign frame loads distributed, and for 1 meter height we have already found out the load, which is 2.5 kilonewton per meter, right? So 2.5, or otherwise you can calculate it again. 0.125 parapet wall we are considering, 125 mm parapet wall, multiplied by height is 1 meter, so you can directly write 1 meter multiplied by 20 mm, sorry 20 kilonewton per meter cube unit weight per meter run for 1. So you can click on enter, you can see 2.5 it is we are getting. So now for this lift room, so I will select the lift machine room beams, I will select the stair room beams, and I will calculate it. It will be thickness, I will consider the same, 125 mm. So 0.125, 125 mm. Asterisk for multiplication. 2.5 we are considering the height, minus beam depth we are considering 0.4 that we have taken, multiplied by 20 kilonewton per meter cube. It is the unit weight of the material, that means the brick, red brick, multiplied by 1 meter run. It is not required, so you can click on enter. This is 5.25 and click on apply and OK. So if you see now in the 3D view, we have assigned the loads. Okay, I think we don't have an let me just check whether we have a, is not showing load here. Why? So selected objects only. Is it not the beam? Yeah, it is beam. Let me just right click on this beam so that we can see the loads. Yeah, it is assigned. So but it is not showing. Fine, I think it is there. Yeah, you can see it is there, but for some reason it is not. Yeah, see it is, yeah, it is coming actually, but as we have this opening, for some reason it is not showing. Okay, so it's not an issue. Right click and show all objects. These are there actually. Okay, I'll click on 3D. What you can do, you can increase this sizes also, text sizes. If you go to options and if you go to graphic preferences, here you can see maximum graphic font size. You can change from 6 point to maybe 10 points. And let me see, is the maximum one. Okay, you can see, okay, it is not changed. Options, graphic preferences, maybe I will change this one also as 5. Okay, it is not changing anything here. It as default. I think it was 6 and 3, right? Okay, okay, fine. So we can see that it has assigned the loads actually here, but it is not visible some reason. Okay, here 5.25 we can see. Now what we'll do, I will go to the plan view of 6th floor. That means my this one, top floor. Now here I will delete this opening because we need to provide a slab for the you can say lift machine. So we'll be keeping the lift machine here, right? And this is my fine. It is totally fine. Now I will go to define section properties, slab sections. As there will be a very heavy load, what we can do, maybe we can change this. We can make a copy of this slab and we can make a S2 of 150 mm thickness. I'll click on OK. Everything will be same, shell thin M25 grade slab. OK. OK, I'll select this one, rectangular floor. Make sure this is one story, okay, because all the changes we are doing it only in this particular floor. I'll select the property as S2 150. I will draw the floor here. Okay, now we need to actually calculate. Now what I will do, I will select this particular portion. Okay, and I will select this particular portion. Fine. And what I will do, I will replicate this to the story 7 and apply. Okay, if you go to the story 7, here I need to make some changes. What are the changes I need to make? Here this slab we need to delete. This slab also I will be deleting because I will be changing the loads. So I will select the slab here. I will make it S1 125. Actually I will draw a slab like this. Okay. Now on these slabs there is no need of any extra you can say loading at the dead loads. Okay, you can select this and you can assign shell loads. I will just assign a single load here, so uniform. I will select the live load here, and maybe I will assign the minimum live load for the you can say roof, that is 0.75 that I have explained in the previous video. You can apply it. I will go down. Now here for this particular area I need to calculate the load. Okay, I need to calculate the stair load. Okay, so again for this roof also I need to calculate the roof load. So what is the roof load? Let's just assign the roof load first, then we can change. So I will go to define and I will go to you can say load shell load uniform load sets. I'll make a copy of any of these loads, maybe add copy of load set, and I will make it dead load equal to 1. So why I am considering dead load 1? If you are considering suppose the you can say waterproofing, okay, so in that case the load we need to calculate for the waterproofing also. So it will be coming around 1 to 1.2. I am considering 1 only for the dead load, and live load we are considering 1.5, considering the roof as accessible roof. Okay, so I'll make it roof and I'll make the SIDL as 1, the live load as 1.5. Okay, I'll make a copy of this. I'll select all these slabs. Okay, let me just click on OK. I'll select all these slabs. Maybe this balcony. Okay, let me just select all these tabs. Problem. Not this one, because this is the lift machine room. Selecting not this one. This is the stair one. As we have provided a actually you can say this one here, so I think there is no need of, we have provided parapet wall here, right? There is no need of assigning the load on these slabs also. Still okay, it's fine, just select it. Okay, now we can assign, actually I do not want to assign on this cantilever, but still okay, let's select this. Okay, I will assign shell loads uniform load sets. I'll click on this roof and apply. Now what I will do, I will be creating another load set for this lift machine, right? So let me just close it. Now we need to calculate the load for the lift machine room. Okay, so let us calculate first what is the load that we are getting for the lift machine room. See, this lift machine room, if I show you in the CAD file, it is of 1.95, that means considering 2 meter by you can say 1.5 meter. So you can consider that in this lift machine room, that it means this area, it will be a lift for 4 to 6 persons. So obviously 6 persons you can consider here actually for 2 meter, 1.5 meter by 2 meter. So if it is 6 persons lift, so let us just calculate as obviously this is not the exact one, it is the arbitrary way, because the lift loads will be given by the lift company themselves. So let us just select calculate this. So suppose the number of persons we are considering 6 persons. Okay, 6 persons. Okay, and weight of one person we are considering average, on an average of maybe 60 kg suppose. Obviously you can go more, 70 kg also. So on an average we are considering one person is 60 kg. If I convert it to Newton, so it will be 60 multiplied by 9.81 will be something around let me just write 60 multiplied by 9.81 will be 588.6. 0.6 Newton, right? So for 6 persons it will be, 6 multiplied by 588.6 equal to 588.6 multiplied by 6. It is something around 3. It is 3531.6 Newton. Okay, for 6 persons. So we are considering the total load as dead load. Okay, we are considering the total load as dead load. Even for these persons also we are considering the load as dead load, because when the lift will be moving, that load will be constant on the lift actually. So I am considering this as a dead load. Now what we need to do, the company from which you will be purchasing the lift, they will be giving you what is the load that you will be having for the lift machine. Okay, the total lift, you can say assembly, that will be on top of your lift machine, you can say the compartment, and the whole lift compartment, what is the total weight, it will be given by the company itself. So for now, suppose the weight of, you can say, the lift machine, we are considering, suppose 2000 kg, which is given by the lift company. If I convert this also into Newton, how much it will be? It will be 2000 multiplied by 9.81. So we will get it as 19620 Newton. Okay, so how much total load? This is the lift machine load. This is my load of the people who will be there in the lift machine, right? Means in the lift, will be using the lift. So it will be in total 3531.6 plus 19620. It is something around 19620 plus 3531.6. So it is 23151.6 Newton. If I just change it to kilonewton, so what we need to do, we need to divide it by 1000, then we will get it as 23.123, so 3.1516 kilonewton, which we can write it as, suppose, 23.2 kilonewton. Okay, or 23 kilonewton you can write. Okay, I will write it, suppose, 4 kilonewton. Okay, on an average I have made it 24 kilonewton. Now this 24 kilonewton load will be, this is the kilonewton load, right? This is kind of a point load. Now this 24 kilonewton we need to distribute on the area that we have for the lift machine, right? So it need to be kilonewton per meter square load, right? So if I divide this, let me just find out the area that we have for this lift machine slab here. Okay, so I'll go to this draw, you can say dimension lines, and I will just draw the dimensions from here to here, from here to, okay, so it is 2.17, so 2.2 multiplied by 1.8. okay, so if I just go here, so the load, the total dead load per meter square area, it will be 24 kilonewton divided by, if I just show you how much, what, 2.2 by 1.8, right? So 2.2 multiplied by 1.8. So this is my area of slab which will be taking this load, and this is the load, right? So kilonewton, and we have meter square. So how much it will be? will be 24 divided by 2.2 multiplied by 1.8. This is 2.2, remember 2.2. Yeah, so it is something around 6.06 kilonewton per meters. So on 6.06, so you can register 6 kilonewton per meter square. Total dead load will be assigning as for the lift machine. Now in the lift machine room, there will be no extra live load, only for the maintenance purpose the people will be accessing this. So the lift machine room, so in that case live load we will consider the minimum live load of 0.75 kilonewton per meter square. So it is as per IS 875 part 2, right? Now I will go back to my ETABS. I will go to define. Here you can see shell uniform load sets. I'll make a copy of any of this, add copy of load set. Now here I will write D equal to 6 comma L equal to 0.75. I will write it as LMR, lift machine room. Okay, so dead load is 6, live load is 0.75. Click on OK. Okay, this is one story. I'll select this lift machine room. Let me just cancel it. Press escape. Select this lift machine room. Assign shell loads, uniform load sets, and I'll click on this LMR. Click on apply and OK. Now if you go to the 3D view, you can see we have created the model. Here we need to change the height, so I'll go to edit stories and grid systems. I'll click on modify story data, and I will change this height to 2.5 meter. Also I will change the height of my stilt floor as also 2.5 meter. Okay, now I'll click on OK. I'll click on OK here. So here you can see we have assigned all the loads. You see the loads of the walls, you can see that also. Now okay, here at the top it should not be there, actually we need to delete this. I'll go to floor plan, story 7, make sure it is one story. I will select all this. Okay, I will select all this. I'll go to assign cell loads, sorry, frame loads distributed, SIDL, and delete existing load. On top there will be no load, right? On top there will be no wall load. Okay, so this is the load that we have assigned on all the whole structure, and the modeling of the structure is finished. So I will just go to the plan view of base level. I'll click on this show undeformed shape, make sure it is one story. I will select the whole base, all the points. Okay, and now what I will do, let me just see if there is an extra point I have. Right, and I'll click on assign joint restraints. I'll click on this fixed. I'll click on OK, apply and OK. Now why I have made it fixed, I will be explaining in our later session. Okay, this is the kind of, you can say, the detailing we do, or the, you can say, assumption we make. Depending on that we actually make it fixed. Okay, so why we have made it fixed I will be explaining in our later sessions. So this is it for this session. We will start analyzing our structure. We will check the structure again in our next lesson whether there is any error, and then we will start analyzing the structure and we will see the other aspects of it. So thank you and see you in the next lesson.